Good morning. Welcome to today's session on Blockchain Explorer activity. In this video, we will learn how blockchain transactions are recorded and verified using a Blockchain Explorer. By the end of this session, you will be able to search a real blockchain transaction, identify its key details, and complete the learning activity independently. Before we start, I'm going to ask you a quick question. How many of you have ever double checked a transaction on your bank's app? No. How many of you could show me the bank's actual internal ledger? Nobody can, right? That's the exactly gap we are closing today. A blockchain explorer is what is look like when that ledger isn't locked away. It is public, searchable, and anyone with a link can verify it. That's what we are going to do in a hands-on session. I'll show you how to track transactions, a time, and where it from, how hashes or how input hash will look and output hash will look. You need to go do it your own and take a screenshots and observe it and write it as an assignment and submit me in this session. Our objective is to understand how blockchain transactions are publicly recorded. We will explore a blockchain explorer, examine the transaction information, and learn why blockchain technology is transparent and secure. The three words are very important in this. One is public, permanent, and verifiable. Public means no login needed to inspect a transaction. Permanent means data cannot be edited. Verifiable means anyone can check the sender's claim. So these are the main part of this session. Now we are going to see about what is Blockchain Explorer. A Blockchain Explorer is similar to Google for blockchain data. Instead of searching website, it searches blockchain records. Every confirmed transaction is permanently stored on the blockchain and can be viewed using these explorers. Since blockchain is decentralized, everyone can verify transactions without relying on a central authority. Explorer is basically a Google, but scope would be one blockchain's public ledger. Now we are going to see about blockchain.com Explorer and Ethereum Scan. And blockchain.com Explorer covers Bitcoin, Etherscan covers Ethereum. Both are free. We no need to pay for an account or no need an account. It shows an index of the entire history of their chain right back to the first block ever mined. Every node works independently and it stores the identical data of its type. We can see it from its trusted sources. Thousands of computers already agreed on it. That's why it shows a trusted data only. Now we are going to see about anatomy of the blockchain transaction. This is the anatomy of a blockchain transaction. It contains the transaction ID, sender address, receiver address, transaction amount, transaction fee, timestamp, block number, and confirmation status. Every blockchain transaction has an unique transaction ID, also known as a hash. The sender address identifies the wallet that initiated the transaction, while the receiver address identifies the destination wallet. The transaction amount indicates the cryptocurrency transfer, and the transaction fee is paid to miners or validators. Each transaction is stored in a specific block and receives confirmations as new blocks are added. In this slide, I have inserted a screenshot of a blockchain transaction page. Now I'll show you a live demo video for this transaction. Think of it, if a blockchain.com's website went down tomorrow, would the data be lost? Actually, no. It lives on the network. The Explorer is just one of many possible windows on it. That's all. Next, these are the activity steps which we are going to do. First, you need to open an Explorer, name blockchain.com Explorer for a BTC transaction, I mean Bitcoin transaction, or Etherscan for Ethereum transaction. Pick any one, stick with it for this activity. Next, search for a transaction. Paste a transaction hash. I'll give you some sample hash, or use your own hash or your friend's hash, and search for it. And locate the fields in the transaction page. Five fields actually. What are the five fields, or I'll show you in the next slide. Then capture it, capture a screenshot, and write down what the each block is, and in your own words, right? These are the demo. First step, you need to open a blockchain explorer and paste a transaction hash into search for. Once the transaction loads, identify the transaction ID, sender, sender address, receiver address, and what are the amount transferred, then block number and confirmation status. Okay, now we are going to see about demo video. In this, open your Google, then search for blockchain.com Explorer, or Etherscan, whatever whatever you want. You need to give. You can give. Actually, I have chosen blockchain.com Explorer. And this, I'll give a blockchain.com Explorer. I'll select the blockchain Explorer. It is for Bitcoin tracker. Then it shows the page like this. In this, you need to select latest transaction. In this side, you see the transactions. You select any one of it. See, this is a Bitcoin transaction. This is the hash addresses. This is the hash from where output values input. This is the from hash value to the to receiver hash value. If you have a hash value only now, you can copy this hash value and paste it in the search box. It will show which block is there related to the hash value, and you can see the transaction history, what are all made based on this hash ID. This is the demo video. Like this, you need to search in your laptop or on your system, in blockchain.com Explorer or in Ethereum Scan. Then you should take a screenshot of it, and you need to write what are all the things you have observed while doing the demos, while seeing the Bitcoin page or transaction page. You need to write about it, and you need to submit it as an assignment. These are the five fields you need to identify and note down it. First, transaction ID. It is a unique hash ID. For this transaction, think it is it's like a receipt number, but we cannot reuse or duplicate it. Second one, sender and receiver address. It is a wallet address which funds will be moved between, like account numbers, but it won't be a public one. But it is a public one. Sorry, it is a public one. Then transaction amount. How much moved, plus network fee paid for miners or validators, like that. Next one is block number. Which block this transaction got permanently sealed. Like page number in a ledger book. Then confirmation status. How many blocks have been added since this one? How many pages have been printed on top of this page? These are the five fields you need to go through the web page or an explorer page, and you need to note down, and you need to submit, right? One of the major advantages of blockchain is transparency. Every confirmed transaction becomes a permanent part of the blockchain ledger. Although wallet addresses are public, the identities of users remain anonymous unless disclosed. This transparency makes blockchain highly suitable for industries that require trust and traceability. Okay, the blockchain provides public visibility, then data integrity, then immutability, trust, and decentralization. Uh, where and all, what are all the applications are using blockchain? Mainly, that is using in banking application, then healthcare, then supply chain management, then cryptocurrency, and digital identity. These are all the major applications which are using the blockchain. Now it is your turn. Open a blockchain explorer and search for a blockchain transaction. Can fully observe the transaction details and capture screenshots of the record fields. These screenshots will be submitted along with your observations, right? First screenshot will be a full page screenshot with the URL visible. Then only it proves that you actually did the search. Next one, a soft observation write-up for some 7 or 8 questions. Your own sentences, 1 or 2 sentences with your own words. What did each field shows you? Then you need to screenshot the blog page also. See what other transaction got bundled with yours. On another reflection line, you should write what would it take for someone to fake this record. Okay. Okay. Now let's discuss what you have learned. What will your learning outcome? Step back for a second. You didn't just learn where 5 fields live on a web page. You just personally verified 2 properties that make blockchain genuinely different from a bank ledger. First one is transparency. You looked up a transaction that wasn't yours with zero permission needed and read it as easily as your own. No bank lets you do that with a stranger statement, right? Anyone, anywhere can independently verify a transaction happened. No bank, no permission, no gatekeeper. This is a biggest proof that you can view any transaction publicly, right? Then next one is immutability. That confirmation count you recorded isn't just a number. It's a direct measurable answer to how locked in is this record. The higher it goes, the closer to physically impossible it becomes to alter. Once confirmed and buried under later blocks, the transaction record is effectively permanent. Rewriting it or modifying it is not possible, right? You can go and check your transaction by editing it, but you can't do it. So transparency and immutability is a biggest learning outcome from this video or this session. While seeing the transaction page, you will you will come to know that transparency and immutability is a giving power for blockchain. Next, before going for a discussion, I am going to tell you about what should you need to submit. For submission, upload the screenshots of the transaction details and block details. Additionally, answer the 7 questions listed in your assignment page. These observations will help your understanding of blockchain transparency and immutability. Okay, now we are going for a discussion. Let's think of it. If addresses aren't names, is this truly anonymous? or something else. What's the word for that? Think of it. If you know, if think of it and write down and send me, or else I'll tell you now. Identity isn't attached, but every moment is traceable. Okay, because we don't know the identity, but we can transact. We can see the every moment and permanently linkable if an address is ever tied to a real name. But if we are not seeing a real name, we are seeing only a hash values, right? The next one. Why does the number of confirmations matter more than just it is on a chain? Actually, a transaction can technically be on a chain with 0 or 1 confirmations and still theoretically be reorganized out. In this, we are going to learn about how practically it is final one, right? Then, what's the real difference between this and your bank app? Trust is the biggest part of key difference between both the bank and this blockchain. A bank asks you to trust them, but a blockchain lets you verify it yourself. There will be a thousand of independent copies, but blockchain lets you verify it yourself. That's the main part of it. Okay, you didn't uh, take a transparency immutability on faith. You yourself going and verifying there and you yourself check their transparency immutability is possible in the blockchain, right? So, in this session, we explored how blockchain transactions are recorded and verified using a blockchain explorer. We learned about transaction IDs, valid addresses, block numbers, and confirmations. I actually encourage you to complete this activity independently and explore additional transactions to deepen your understanding. Thank you and do your activity. Happy learning. Thank you. Okay, this is the questions. Uh, you need to observe and write down it, and you need to take screenshots of transaction details and block details. Kindly go through these questions and open a blockchain.com explorer or Etherscan and do the process and write down it and attach it as a soft copy in your Sprout LMS, right? You have some any doubts while doing this? Mm, kindly make a call for me and I'll clarify you, right? Thank you. Thank you.